Hey guys, this is the last problem I'm taking up on convolution sum. This problem is kind of lengthy, but the thing is, not to make the video shorter, I have done some initial work here. Let me explain you what I have done. So the problem is determine convolution sum of x of n and h of n. Okay, x of n is sequence is 1 for n varying from 0 to 4 and equal to 0 otherwise, and h of n sequence is alpha power n. It is actually exponentially increasing signal. Why? Because magnitude of alpha is greater than 1. So, and it is for n varying from 0 to 6 and equal to 0 otherwise. So as a solution, I have sketched x of n and h of n. Let me show you. So x of n is 1 for n varying from 0 to 4, right? So for n varying from 0 to 4, for n varying from 0 to 4, its amplitude is 1. Okay, and is 0 otherwise. And what is h of n? It is alpha power n, and magnitude of alpha is greater than 1, and n is varying from 0 to 6. So n is varying from 0 to 6, and he said that alpha is greater than 1. So if say alpha is 2, just I'm assuming to convince you it's an exponential increasing signal. So if alpha is 2, what is our h of n? H of n is what? Alpha power n, right? What is 2 power, when n equal to 0, what is 2 power 0? It is 1, right? When n equal to 1, what is 2 power 1? It is greater than 1, right? And if n is 2, it is again still more greater than 1. So more greater, right? So therefore it is basically a exponentially increasing signal. Fine. So I have taken mirror image of h of n, which is h of minus n. This is how it looks like. It is just nothing but flipping of this sequence. So this is 0, this does not change, it remains in the same position, whereas 1, 2, 3, 4, 5, 6 goes to minus 1, minus 2, minus 3, dot 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 minus 6. Okay, so I did not write the value of this sample because we don't know what is the value of alpha. So this I know because anything to the power 0 is 1. So that's why I had taken this as 1. Okay, so what is the next thing I need to do once I plotted x of n and h of minus n? So I had to replace the independent variable from n to k, right? So this is now k, x of k, this is k. Now this is h of minus k, and this is also k. So once I got x of k and h of minus k, what is the next thing I need to do? So I have to bring these two sequences in a single independent variable k, right? So which I have done here. So x of k and h of minus k, I have put it in a single independent variable. X of k was varying from 0 to 4 and its amplitude is 1, right? And h of minus k was varying from minus 6 to 0 and it is an exponentially increasing signal, right? So both signal, so this and this are in 0th, k equal to 0th. Just to distinguish, I have just kept it further apart. Okay. Okay, what is the next thing I need to do? So what is the next step? Step 3. Step 3 is to assign the slider index, right? So where is this sample? It is at n equal to k equal to 0, right? So now this is n, right? The thing is, in the previous problems which I solved, the sequence was actually infinite in length, where I could access only one end of the sequence. The other end of the sequence was either plus infinity or minus infinity, which I could not reach, so I could not assign the slider index. Whereas in this example, I can assign slider index to both the end, right? Because it's a finite length. So now this is at n k equal to 0, so this is n now. Now this is at k equal to minus 6. What is this slider index? It is nothing but n minus 6. Okay, hope it is convincing. Now just to decide what and all the overlapped regions and what and all not are overlap regions. So as I told you, it's a bit lengthier, so I made my best to convince you the figures here. Okay, so what is the first thing I need to do? I need to take this slider index and I have to I have to keep this in minus infinity, and I have to move this sequence from minus infinity to plus infinity, and I have to see what and all the overlapping region, right? Now what I did was, so I took this and I kept it here, okay, what I did is I kept this sequence just before 0, which is minus 1. Okay, so here just before 0, which is minus 1. Why I kept it here? Because till here there won't be any overlap, right? When I move it right further, overlap starts. So I kept it at -1. So from minus infinity till here there is no overlap, right? So my output is 0. Now in the second case I'll move it right further. That's what I did. I kept this slider at this is n, this is n minus 6 now. Again this is n minus 6, n minus 6, n minus 6, this is n minus 6. So I just kept this to 2. So I just kept this n to 2. According to the other end also will move right further, right? Now till where I can move right? Till I can move this n slider till it touches 4. Okay, this is the boundary for n to move, so I can move it from 0 till 4, till it touches 4. That will be my case 2. Okay, this is one region of overlap. Fine. Now in case 3, once it touched to 4, I can move it right further, right? Now till where I can move right after 4, so that these two overlap, these two sequence, this 0 to 4 sequence will remain in the region of the bigger sequence n minus 6 and n. So I can move this only like this, where the overlap region does not change, it remains constant. That is the region 3. Now I can move it right further, right? Something like this. Again it has a boundary till where I can move it right till n minus 6 reaches 4. Okay, so that is the boundary to move my slider here, this sequence. Fine. So I can move this n minus 6 only from here to here. That will be the next overlap region. Now once I reach here 4, till where I can move it right further anywhere, because there won't be any overlap, so it will be 0. So let me repeat it again. This is the non-overlapping region where I kept n less than 0. Okay, and I moved this n further right. So I can move it. I have the boundary only. I can move this n from 0 to 4. Okay, this is the next region. Now once I reach that to 4, I can move it right further, but still again there is a boundary where I can move only. I can move for this portion where these two are in the same region. Okay, now once I reach this, once I reach this n minus 6 to 0, I can move it right further, right? Till where I can move it right further, till this n minus 6 is in between 0 to 4. That will be my another overlap region. Once this n minus 6 region reaches to 4, till I can move right, till I can move, I mean I can reach till infinity, because there is no overlap. So these are the 6 overlapping and non-overlapping regions we get in this problem. Okay, I hope this is convincing. Now I need to get the equation for case 1. This is 0, y of n is 0 because there is no overlap. Case 5, again this is 0 because there is no overlap. So this I can write directly, y of n equal to 0, y of n equal to 0. Now I have to write the equation for case 2, case 3 and case 4, which we will do it now. So case 1. So what is the figure of case 1? Case 1 is there is no overlap region, right? So x of k sequence is varying from 0 to 4, and h of minus k sequence is like this. This is actually slider which is n, this is actual slider which is n minus 6. So this is k, right? Since there is no overlap, what is y of n? So what is the condition? N is less than 0. So when n is less than 0, there is no overlap, so y of n equal to 0. Why? Because no overlap, because there is no overlap. Fine. So now case 2, this is for case 1. So case 2, I have to move it right further. I have to move this sequence right further. So 0, 4. Say this is somewhere here and this is somewhere here. This is n and this is n minus 6. And this is k, right? And what is the overlap region? Start from 0 and ends at where I keep my n value, and n has restrictions that I can move this n only from 0 to 4. right? What is the condition? This is for n greater than or equal to 0, for n greater than or equal to 0, and till where I can move n, till I can move less than or equal to 4. So combinedly I can write it as n is in between 0 to 4. Okay, so what is y of n? What is the formula? Formula is summation k varying from minus infinity to infinity x of k h of n minus k. So y of n is equal to, what is the overlapping region? K start from 0 and ends at k, ends at n. What is x of k? X of k is a 1, right? It is 1. What is h of n minus k? It's a exponentially increasing sequence, right? Where is the problem? Okay, if h of n is alpha power n, what is h of n minus k? It is nothing but alpha power n minus k, right? So I'll write it as alpha power n minus k. So y of n is equal to summation k varying from 0 to I'll write it as n plus 1 minus 1, plus 1 minus 1 cancels out, I end up with n, and alpha power n, alpha power minus 1 whole power k. So I split it up into alpha power n and alpha power minus k, and alpha power minus k I wrote it as alpha power minus 1 whole power k. So y of n is equal to, since alpha power n is independent of k, it has nothing to do with k, so I'll take it out, and left out term is summation k varying from 0 to n plus 1 minus 1 alpha power minus 1 whole power k. Okay, so this is in the standard form of, this is in the standard form of what? Summation n varying from 0 to n minus 1 alpha power n, right? So what is the result of this? 1 minus alpha power capital N. This term has to come here, whole divided by 1 minus alpha, right? So this is equal to alpha power n, this term, into this is 1 minus alpha power, this term has to come here, this term is actually it is n plus 1 whole divided by 1 minus alpha. So we have to simplify further, so I can write it as alpha power n into 1 minus alpha power, so it is minus n, minus into minus, minus 1 whole divided by 1 minus alpha power minus 1. So I'll continue it from here, I'll continue from here. So I'll multiply this alpha to the power n to the numerator. So what do I get? 1 into alpha power n is, so y of n is equal to, so 1 into alpha power n is alpha power n, and alpha power n into alpha power minus n minus 1 is nothing but this term plus one more alpha, right? One more alpha power n, right? So this is nothing but minus of alpha power minus n minus 1 plus n whole divided by 1 minus alpha power minus 1. Okay, so minus n plus n cancels out. Y of n is equal to what? Alpha to the power n minus alpha to the power minus 1 whole divided by 1 minus alpha to the power minus 1. So I'll multiply both numerator and denominator by alpha. So y of n is equal to what? Alpha power n plus 1 minus alpha power minus 1 plus 1 cancels out. So this is 1 whole divided by, this is alpha minus, again this is minus 1 plus 1 cancels out. What I do, I'll multiply both numerator and denominator by minus 1. So I end up with y of n is equal to 1 minus alpha power n plus 1 whole divided by 1 minus alpha. So this is the simplified equation for case 2, where n is in between 0 to 4. Okay, now, so now case 2 is done. Now we'll do for case 3. So the case 3, so what is the case 3? So case 3 is when n minus 6 and n are out of range of 0 to 4, right? So it is like this. So case 3 is something like this. So this is 0 to 4, and this is n, and this is n minus 6, right? And this is k. What is the overlapping region? Overlapping region is in between 0 and 4, so it is independent of n now, because wherever you move within the boundary of n, it will remain same. So what is the condition? When n is greater than 4, because in the previous problem I included 4 equal to 4, so I have to exclude the 4 here. When n is greater than 4, until where I can move, n minus 6 is less than or equal to, and n minus 6 is less than or equal to, till where I can move 0. Okay, so these are the two conditions, but I can write this as n is less than or equal to 6 if I take this 6 to the other side. So if I combine it, n is in between 4, n is greater than 4 and less than or equal to 6. So this is the range of n which I can move. Okay, so what is y of n now? Y of n is summation k varying from 0 to 0 to 4. The overlapping portion is 0 to 4. X of k, it is 1. This is our x of k sequence, which is 1. H of n minus k, it is nothing but h of n is alpha power n. H of n minus k is alpha power n minus k. Okay, so y of n is equal to, so I can write it as summation k varying from 0 to 5 minus 1. So I'm just bringing it in a standard form, alpha power n into alpha power minus 1 whole power k. I splitted this, so now alpha power n is independent of k, so I can take it out. Y of n is equal to alpha power n, so summation k varying from 0 to 5 minus 1 alpha power minus 1 whole power k, right? Now this is in the form of what? I'll write it here, summation n varying from 0 to n minus 1 alpha power n, right? So this is nothing but 1 minus alpha power capital N whole divided by 1 minus alpha. So now I'll substitute this form here. So y of n is equal to what? Alpha power n, this term, and right hand side of this, which is nothing but 1 minus alpha is alpha power minus 1 whole power, what should I write? 5, right? Because this n comes here, so this 5 has to come here. So 5 whole divided by 1 minus alpha, because alpha is alpha power minus 1 here. Okay, so y of n is equal to, so alpha power n times 1 is alpha power n, minus alpha power minus 5 times n is alpha power minus 5 plus n whole divided by 1 minus alpha power minus 1. So what I'll do, I'll multiply numerator and denominator by alpha. What do I get? Y of n is equal to alpha power n minus, so alpha power n plus 1, because alpha power n times alpha is alpha power n plus 1, minus alpha power minus 5 plus 1 plus n plus 1. So minus 5 plus 1 is minus 4, so it is minus 4 plus n whole divided by alpha times 1 is alpha, minus alpha times alpha power minus 1 is 1. Okay, so what I'll do, I'll just multiply numerator and denominator by minus 1. So y of n is what? So alpha power n minus 4, alpha power n minus 4 minus alpha power n plus 1, this term, divided by 1 minus alpha. This is the output of a LTI system for n in between 4 and 6. Okay, so this is the simplified equation for case 3. Fine. Now we have to go for case 4. What is case 4? So I have to move this slider further right, correct now, which is this case 4. So it is something like this, 0 to 4, and if I move it further right, it is like this. This is n minus 6, and this is n, and this is k, right? What is the overlap portion? Overlap portion is, so from n minus 6 to 4. Okay, so what is the now till what is the range? I mean, how can I move it from where to where I can move? I can move from just after 0 till where I can move, till I can move 4. till 4 I can move, right? Till n minus 6 is 4. So what is the condition? When n minus 6 is uh, did I included, okay, now when I included 0, when n minus 6 is less than or equal to 0, so I should exclude 0, right? When n minus 6 is less than 0, I'm sorry, when n minus 6 is greater than 0, when n minus 6 is greater, I cannot put greater than or equal to 0. Why? Because I have already included 0 here. Okay, when n minus 6 is greater than 0, till greater than 0 in the sense here, right? Till where I can move? Till and n minus 6 is less than or equal to 4. Okay, so okay, how do I write it in terms of n? If I take this 6 to the other side, when n is greater than 6, if I take this to the other side and n is less than or equal to 4 plus 6 is 10, right? So if I write it combinedly, it is in between 6 and 10, when n is in between 6 and 10. Okay, so what is the output now? Y of n is equal to summation k overlap position start from where? N minus 6, right? N minus 6 till where? Till k equal to 4. X of k, it is 1, and h of n minus k is nothing but alpha power n minus k, because h of n is alpha power n, therefore h of n minus k is alpha power n minus k. So kind of lengthy simplification we have here. Okay. Now I need to bring this right hand side to 0, in the sense lower limit I need to make it 0. So what did I say in the previous videos? How do I make this 0? It is nothing but you bring this to the other side, left hand side, and equate it with a dummy variable, right? So what I'll do, I'll put k, if these two goes to the other side, what happens? Minus n plus 6 is equal to m. So I'm equating with a dummy variable m, and I have to write it in terms of k, right? So what is k now? K is equal to m minus n is plus n plus 6 is minus 6, right? Now in this summation, wherever k is there, I am replacing it by m plus n minus 6. So I'll do the simplification from here. So what do I get here is y of n is equal to summation, so k, but what is k? K is m plus n minus 6 is equal to, what is this? N minus 6. And what is k? K is m plus n minus 6 is equal to where? 4. So k is equal to m minus 6 to k is equal to 4. K is equal to n minus 6 to k is equal to 4, right? Okay. Now alpha power n minus k, right? But what is k? M plus n minus 6, right? So y of n is equal to, now I have to write the upper and lower limit in terms of m. So n cancels out, 6 cancels out, and this n minus 6 goes to the other side. So summation m is equal to 0 to m is equal to, so 4 plus 6, it is 10, minus plus n is minus n. Okay, so it is nothing but 10 minus n. So alpha power n minus m plus yes, it is n minus m minus n plus 6, right? This n cancels out. So what do I get? Y of n is equal to summation m varying from 0 to 10 minus n alpha power 6 minus m. Okay, now I'll bring this to the standard form. Y of n is equal to summation m varying from 0 to, I'll write it as 11 minus n minus 1, so that it is 10 minus n. Okay, so and this is nothing but alpha power 6 into alpha power minus 1 whole power m. I just splitted this alpha. Now alpha power 6 is a constant, I can take it out, right? So y of n is equal to alpha power 6 into summation m varying from 0 to 11 minus n minus 1 alpha power minus 1 whole power m. Okay, now this is in the form of summation n varying from 0 to n minus 1 alpha power n form, right? So the right hand side is what? So alpha power 6, I'll put it same. So it is 1 minus alpha power this term 11 minus n term whole divided by 1 minus alpha. Okay, now y of n is equal to, so I'll multiply this alpha power minus 6 to the other side. So 1 times alpha power 6 is alpha power 6 minus, so this is nothing but alpha power minus 11 plus n, and this is 1 plus 6, right, divided by 1 minus alpha power minus 1. Now, minus 11 plus 6 is minus 5, so I'll write it here. I hope this can be managed in this sheet itself. So what is y of n? Y of n is equal to what? So alpha power 6 minus alpha power n minus 5 whole divided by 1 minus alpha power minus 1, right? So I'll multiply numerator and denominator by alpha. So y of n is equal to what? Alpha power 6 plus 1 alpha is alpha power 7 minus alpha power n minus 5 plus 1 is minus 4 whole divided by this is alpha times 1 is alpha minus 1, right? Okay, now this is equal to what? I'll just multiply numerator and denominator by minus 1. So y of n becomes alpha power n minus 4 minus alpha power 7 whole divided by 1 minus alpha. So this is the output of a LTI system for n varying from 6 to 4. So this is case 4 equation for the overlapped region. Okay, now what about case 5? What about case 5? Now case 5, when I move it right further, y of n is 0. So for case 5, case 5 is what? For n greater than, so I have included, so n minus 6 is less than or equal to 4. I have included 4 here. So case 5 will be what? For n minus 6, for n minus 6, this n minus 6 is greater than 4, or I can write this, if I bring this to the other side, n is greater than 10, right? So for n greater than 10, what is y of n? Y of n is 0. Why? Because there is no overlap. So this is the equation for the last case, which is 1. So y of n is equal to, so I need to write the output equation. So case 1, okay, so y of n is what? Y of n is 0 for n is less than 0, right? So it is 0 for n less than 0. This is for case 1. For case 2, what is the equation? This equation, right, which is 1 minus alpha power n plus 1 whole divided by 1 minus alpha. And what is the condition for n? So for n is in between 0 and 4. So for n in between 0 and 4. This is for case 2, right? And case 3, this is our case 3 equation for n varying from where to where? 4 to 6, less than 4. So it is for n in between 4 to 6. So y of n is alpha power n minus 4 minus alpha power n plus 1 whole divided by 1 minus alpha. Okay, this is our case 3 equation. What about case 4 equation? So this is our case 4 equation, right? This is the case 4 equation, which is this. And for what value of n? In between 6 and 10. So for n in between 6 and 10. So this is the equation we have, so which is alpha power n minus 4 minus alpha power 7 whole divided by 1 minus alpha. And what is the last case we have? The last case is for n greater than 10. So for n greater than 10, what is the output we have? So it is 0. So this is the final output of a LTI system.